Thanks a lot for coming to my talk. So today I will be talking about test containers and WireMock for C and C++ development. So the first question, have you ever heard about these tools? Okay, as expected, because these tools come from the Java world, but today I actually want to show how to use them with C, C++, and actually develop some real stuff with them. So I work for WireMock, and first disclaimer, so I've been ill with pneumonia in November, so I might be coughing, but I'm not infectious anymore, proven by the blood tests. Okay, so do you recognize this command? Would I still use make files? CMake? Okay, I use CMake. But yeah, make IT is a kind of common pattern for integration tests. So if you want to launch something to test two components together, then you could run this command normally to actually run not just unit tests, but advanced tests that verify multiple components. And for integration tests, I guess nobody likes writing them. Because, yeah, there is a lot of glue code involved. Sometimes it requires multiple technology stacks, many teams maintaining different components. Each of them may be using C++ differently. Yeah, there are so many ways to use C++. And actually, it's always a challenge for automation engineers and developer tools developers to make the things working together. For example, as a part of continuous integration pipelines. And yeah, as developer, I have never liked writing integration tests. I was doing it actually quite a lot for various projects, including, let's say, online billing platform written in C, C++ 10 years ago. So I understand that it hurts. And yes, integration tests, they might be difficult, and they are normally difficult, especially when you work in hardware and embedded space where I come from. But sometimes, if you use proper tool chains, if you use proper frameworks, you can simplify them a lot. Who does write integration tests on your own? Okay, and what do the rest of the team do? Do you rely on QA team? Do you rely on other engineers? Or do you just ship to production? Okay. Well, it depends. And yeah, actually your developer experience and your experience as a team and as a product organization depends on how you approach which technology stacks you take and which tools you take. And yeah, today I'm actually representing two tools, WireMock and Testcontainers. And yeah, I want to show how to use them for C, C++. So I have a short puzzler for you. Who can read this sentence? I tried. Yeah, so it is shift left your integration tests with test containers or WireMock. Actually, in our community, we had quite a long debate what operator to use here. But I deliberately decided to take bitwise OR because both WireMock and test containers have different capabilities, but they actually can achieve the best by if you combine these tools together. And this is what I'm going to present today. And yeah, my slides are already public, so you can take these slides using this QR code. This slide deck is actually really long, but I hope to not spend too much time on that and switch to IDE as soon as possible. So we will briefly talk about what I'm doing here, why WireMock works on C, C++ support, then we go through containers, test containers, and then we return back to WireMock and using the whole technology stack with it. So who does use Docker and any kinds of container automation? Who does need introduction into that? Okay, that's good. I still have a few slides. So yeah, as I said, I work in open source. I actually work on developer tools. I started my career in hardware embedded. I got PhD in electronics design. And when you develop electronics and embedded systems, you need to do quite a lot of automation, test automation, and unfortunately, integration test automation. So for that, I had quite a lot of tools. And I started contributing to Jenkins in 2012. In 2014, I became a Jenkins core maintainer. Now I'm a governance board member, I guess for another week or two, because I'm stepping down to let others to take this role. And yeah, now I actually consult and help others to develop tools, for example, WireMock now, and I also created test containers for C++ to help one of our customers. And yeah, I actually do quite a lot of other stuff. So you can see that, yeah, I might be a kind of one pizza team on my own, so beware of pizza. But yeah, actually I started my career in embedded, and the first my project was fully C++. So there was system written in microcontrollers with mostly C, with the real-time operating system, and there was data acquisition system. And it was about 15 years ago. After that, I actually switched to different technology stacks, but I've been using C, C++ quite a lot at different companies. And my last experience with C++ production development is Jenkins, because do you use Jenkins? So, fun fact that to manage processes on Windows, it actually uses a few native libraries written in C, C++ to work with processes, to extract process metadata, to locate trees and dependencies between the processes. And the whole purpose of that is killing runaway processes in Jenkins, which unfortunately has been quite popular on Windows. So this actually my last production experience with C++. It was something like 4 years ago, but I still caught a bit with there. And actually, given my background, I spent quite a lot of time speaking on embedded hardware conferences. And when I joined WireMock, I also spoke to automotive clients quite a lot, because automotive clients develop a lot of software, and modern connected cars and connected services expect integration testing. So there was a lot of opportunities to apply WireMock. So nobody knows WireMock, right? So in very basic principle, WireMock is a service that emulates your API provider. This API provider might operate with different interfaces. So for example, ISN, gRPC, REST API, and GraphQL, and pretty much every other interface. It's extensible, so you can connect. And a very basic behavior of WireMock and other mocking tools is when you receive a particular request. For example, you can process parameters like path, form, some data you send. You can send a particular response. So for example, here it's just a hello world, but obviously it can be much more complex. And this is what WireMock does. It can be deployed as a standalone service, so you can just run it in your automation infrastructure and connect to that. I get some, is it fine for the audience? Okay, so it's just me. Okay, but you can also do it in the code using various languages. It started in Java, so it looks just like that. So you can write code, and right inside your unit test, you can say that I need to mock the service, mock the particular path, and then do some requests and assert that everything gets processed correctly. So you can test your client-side application, so basically the part that actually talks to remote service modeled by WireMock. So that's the key idea. Does it work? Okay. And yeah, WireMock has been super popular in the Java ecosystem. It has more than 5 million downloads a month at the moment. And it actually expanded to other technology stacks, including Rust, Golang. So there is full native implementation in Rust, full native implementation in Python. Golang has a wrapper, and with all these implementations, the key idea that you can actually isolate from external environment when you write tests. So supposedly, it allows you to firstly run integration tests quickly because you do not depend on external service. It makes the tests more portable, and you can also actually do development if there is still no service implemented that you want to test against. So it's quite helpful. Yes, there is quite a lot of advanced features for API mocking. It's not a point for my talk today, but if you want, we can take a look at the examples. For example, generating different responses, injecting data there, injecting failures. So for example, returning gibberish data, delays, timeouts, and you can also record protocols and then reproduce behavior. You can implement stateful behavior. You can do microscripting. in Java, and somebody created a Lua extension to write actually sequences and the final state machines in Lua for WireMock. Not sure why, but it's available. And yeah, this is all available, and I'm not talking about that today. If you want, we can discuss it later. It's available in many technology stacks, and it has more than 50 different libraries created on GitHub. And when I joined WireMock, actually, we had quite a lot of customers asking whether we could use WireMock or WireMock Cloud. It's our enterprise product for embedded space. So WireMock Cloud is basically SaaS we provide. Again, I'm not talking about it today. It has fancy interface. I'm not showing it today. We will stay in CLI all the time. Okay, so we have customers, quite a lot, that operate in embedded automotive space, mostly developing software. And when you work in this space, one day you write it in Java, one day you write it in Python, then you write in C++, and you want to use the same tool for all these use cases. So we have customers who actually want to use the WireMock for different technology stacks. So it's statistics from embedded space and language popularity. I was actually quite shocked, but yeah, Python now is one of the most popular embedded languages. If you ask JetBrains, they actually say that MATLAB and assembly are the most popular embedded languages. Well, take it with a grain of salt. But in the case of WireMock, when I joined the company in April, actually we had support for quite a lot of languages. There is a mistake, C++ wasn't supported at that point. But the rest, green lights, is actually what we had integrations with. And the question was actually, WireMock is quite cool, it's popular in many languages, but yes, it's not available for C++ development, and actually it creates quite a lot of complications, because we have customers who write automotive software, we have customers who write observability agents in C++, and still want to do all the integration testing. So the idea was quite simple, let's hug these tools and implement them. So this is how test containers for C++ appeared. And this is how WireMock for C++ appeared. And yeah, so I already spent maybe 10 minutes of your time. And the question is whether you want to have a deep dive in test containers and WireMock itself. So just overview how it works, or should we proceed with the demos? Okay. So let's get going. So yeah, integration tests, we don't like them. We want to shift them left. And actually, when we do integration testing, there are 4 different types. So one is testing against production staging. You can deploy the service, you can test against it. This is what everyone does. It's slow, but it's accurate. On the other hand, you can mock on the code level. There are plenty of frameworks in C++ and other languages. So for example, you have a service, you have a client library for that, or just a HTTP client library. Then you mock all these APIs, basically instrument your application, and then run the tests while it's instrumented. It's good, but you do not really test the application you're going to ship to your clients. You do not cover network communications and all the network stack that operates with it. So this approach is quite complicated too. And there are 2 approaches in the middle. So one is testing against simplified or containerized instance. So let's say you have a service, you can put it in a Docker container, so something small, and but still providing your basic function. So for example, you might have large-scale database, but you can still take a small PostgreSQL or MySQL instance in a container, which would be basically doing the same for the purposes of the integration test. Or if it's not possible, yeah, you can just mock on the API provider level, and this is what WireMock is for. Both these approaches are quite fast, and at the same, both these approaches do not modify the client side. So you would be actually testing what you are going to ship in the production. I know it's slightly more specific in C++ because we built different binaries for debug purposes and release purposes, but still, at least we don't have to do even more modifications. And yeah, basically, when you have fast integration tests, you actually do not really have to have integration tests at all. Everything becomes just test because you can put it in the same test suite. For example, if you use CPP unit, if you use Google test, you can just run integration tests there and write the tests with the same framework and the same tooling like normally. So like common unit test, you do the same for integration test. And nobody uses containers, right? So the idea for containers is quite easy. So you can package your tools, bits of your operating system, bits of your environment there, and then you get a container that is distributable, that is portable, that provides the environment that you actually need for tests. The advantages especially for testing is clean environment, because every time you start the test, the environment is clean. So the same as for virtual machines. Also, containers are much faster than virtual machines. So you can, let's say, get a container running in 100 milliseconds these days. Well, I'll try to show it on my laptop, no guarantees. And also, since the containers are portable, you always know what's included there, and you can trace it, and you can reproduce, actually, your builds, your tests, everything where you use containers. Also, they're quite good at clustering, so you can actually build subsystems from containers connected to each other. So in embedded hardware, I started using containers in 2013, basically when Docker just became a thing. And our first use cases was, of course, prototyping and developer tools, because you can actually put your developer tools in a container. For example, we can put a compiler in a container, or Python with all the configuration, dependencies, and especially native libraries that need to be compiled. So you can distribute it through container, and you can do that. Second approach where I started using it is for CI/CD ecosystems, because again, when you have reproducible builds, you normally want to have a reproducible environment there. And it's much easier to do it with a container, because they're fast, they can be disposed, and if needed, for example, if your test fails, you can suspend this container, connect with the debugger to it, and actually get all this environment. And you can take suspended container actually out of the machine to your local instance. So you can do all development and debugging without really relying on your CI infrastructure, without having a kind of Jenkins locally connected to your machine for the debugging, and well, basically other things that all of us used to do. So this is what the container is about. So one of the most popular container engines is Docker. It's 10 years old by now. And yeah, it became really popular in the development space, because the developer experience is perfect. You just run a CLI, you can get everything running on your local machine. Now it's supported on the MacBooks, on Windows, on Linux. So for example, today I'm using Windows, but actually my Docker engine runs inside VSL. No, it runs in Windows. But it's accessible in VSL2, and I don't even care where it runs, to be honest. And yeah, that becomes quite portable, and we can use it. So if you want, I can show you just Docker quickly, how it looks like. But yeah, you know Docker. Okay. Again, this is not something I planned for, but let's say, is it big enough? Okay, so what I can say, Docker run, so there should be, so I say that remove container after the completion. And then I ask for a container, let's say, hello world. So, yeah, this is how it works. This container is thin, so the container itself might include bits of the operating system, or it might be completely small and just relying on the host operating system. So this is basically execution of a container in a virtual machine that does something. Of course, it's not that great. And where am I? So let's. So this is basically what I'm going to show. So it's a test, 3 tests that actually run inside a container, but they're written, and yeah. So there are 3 containers that are being provisioned against which we send test requests that they complete, etc. And it looks like that. Obviously, I think that we should have something more fancy in terms of UI. Can we get it? So in theory, it should, no, it doesn't stream output. But yeah, okay, I don't want to play with parameters of CTest because I forget it every time. So yeah, we can go to, let's say, test containers for Golang. No, not for Golang. Let's take, or I can just show this one. WireMock, test containers, yeah, so test containers, go. So I won't show you a demo, even better, I will show you a picture of the demo. And yeah, it looks like that in real time execution for a container for integration test. And you can see that in this test, we actually provision 2 containers. One is monitor to ensure that all resources are released and that everything is collected after the execution. And then there is a container, Docker IO, WireMock. So it's basically WireMock inside container that provides our with mock API. And then we just run a test that actually executes the thing inside. So yeah, it's quite fast. And if you want to develop the stuff, it's also quite easy. So again, so I've briefly presented WireMock in a container, and I can show how it looks like basically in practice. Sorry, it's a Java one, but yeah, it's basically the same for other languages. I can find something I think in Golang or C++ later. So here we say that we want to use a Java base image. So we take one of GDKs, and then in this container, so we define build steps for this container. And here, for example, we configure the environment. So we use gosu. It's a wrapper for sudo. So it's a bunch of code, but really it's just setting up users, etc. Then we create a directory in the container, download WireMock. Normally, we should check the checksums there, but yeah, this container doesn't do that. And then we basically initialize the environment, like putting mappings directory, putting files directory, extensions, and then we basically just put entry point that will be launched on the startup of the container. And then when Docker builds this container, it saves the states of this container that basically provides a number of layers that are attached on the top of your host system. And when Docker starts, it can easily apply these layers, so it can start quickly. And then you can also extend these containers. So for example, if I want to do something really custom with WireMock, what I can do, I can just build again on the top of this container. And here, for example, so there are a few commands. Where's Docker file? Yeah, so here, for example, what you can do inside the container. Wait, sorry. I actually just lost it, but yeah. So these are examples of running containers with particular commands and parameters. So you can basically do the same. There are CMake containers, there are containers for gperf, etc. So if you want to reproduce particular steps, if you want to debug them, for C++ development, there are already containers for everything because they're being adopted quite well. And yeah, I guess I will show a little bit more examples later because yeah, if you want, we can just build our own container, maybe specifically for C++ code, why not? Okay, does it make sense? Because I just said a lot of stuff, but do you still follow me? Okay. So yeah, so basically the idea of test container is that it's a virtual machine, but it's a very small one that can be distributed and can actually build on the top of your system. Yeah, it's quite helpful. I will still show a little bit more examples later. So test containers, it was created as a framework that leverages container technology for running integration tests in your unit test frameworks. So if you use Google Test, if you use CUnit, etc., you can use a framework, well, basically use a unit test framework, and all of them in different languages are more or less the same. And the idea behind test containers is quite simple. It's a library that basically implements management for these containers, provisioning of these containers, and configuration. So when you run a test, you can just use test containers, say, I want a particular service, configure it like that, and then you just write your test because creation of a container, provisioning gets handled by test containers, as well as release and destruction of the environment after the test. So for example, again, it's a Java example. I will show other examples later if you want. So we can say that I want a container, for example, WireMock. I say a version that I need. So it's official containers, which I briefly shown that we provide. I also configure it. So I say that I want a mapping. So basically, this is hello world file I presented before. So just saying that for particular request, I send a hello world in a response. And then I just write a test. And in this test, I do not care how this environment gets provisioned, because everything is somewhere in the container and managed actually by test containers. So the example in C++ would look basically the same. And here I say that hello world, I just get a server. So test containers maps ports and exposes them to my test. So I don't have to care about this at all. It's randomized. Then I just send a request and process the response. And then the test ends, and something will happen with containers. We don't care because we just run new test. And you may think that it's not possible in C++, but actually it's totally possible. So I can probably jump ahead because I think I shouldn't have provided so many Java examples. But yeah, does anyone use Google Test? Okay, so Google Test, in my opinion, is one of the most advanced C++ testing frameworks. And for Google Test, you can write a test like, where's my test file, actually? So this is a problem when you have a project in C++, because you have a lot of files, but I literally lost. So there should be test CPP there. Do you see it? No. And what I am testing then? Oh, yeah. So I did renaming, and yeah. So sorry for the demo effect. So this is how a very similar test looks within C++. So we will get to it a bit later, but yeah, we say that there is my client test, and this my client test uses WireMock. Is it big enough? And we also have additional endpoint that we use. And then in test, so in Google Test, you can set up test, you can tear down test, so basically like in other unit test frameworks. So here we say that we want to create a new container. And there I say that I want to create a new container that would be based on WireMock. I say that I need to expose port 8080 because this is what is exposed inside the container. So my application inside the container uses port 8080. But I have no idea which port will be actually used by the test because test containers takes care of that, so it's randomized. Then I say that in my test, I will wait until this endpoint, which is admin mappings, will provide code 200. So basically, I wait for the successful startup of my container in the test so that I do not start testing against the system that is not fully initialized, because it's going to explode, most likely. And then I pass a few configuration files in my test. So you can see that I pass hello.json, hello with resource.json, and hello with missing resource, just to test that everything explodes. And yeah, if you want, this test data is here. So again, there is no rocket science. So there is hello world. With the resource, we actually source the response XML from file. It's quite useful for big tests, etc. And with missing resource, I just put something that doesn't exist to verify that actually my framework responds with something. So let's go to our test. So then, after we configure the container, we just start this container and get a container ID. And then we just have our tests. So our test, again, is Google test. So we have 3 definitions there. It uses macros quite a lot. But basically, it will create a test class that will have these test methods, etc. And these test methods, again, like in Java, we just send the request. We do not care about the container, etc. because we have this logic that was created here. We write this logic only once. We can reuse it. It's basically just a class that can be distributed and shared with others. And we write 3 tests where we send the request and process the results. So no rocket science here, just 3 requests. And our main just runs the tests. So Does it make sense to everyone? Okay, we can take a look at other frameworks later because I have a few more examples. Here, so if I launch this test, so basically it's what I presented before. So we just go through these tests, and again, we use test containers for C++. This is a project I created, and everything with WireMock launches like that. So we can test real application by just replacing our HTTP requests, but by actually what we want to test. And if you don't like WireMock for this API mocking, for example, you can do the same for the database, etc. And here's when we actually return to the presentation, I guess, so test containers itself is not just an engine. It's actually a set of SDKs for different technologies. So for example, if you run databases, if you depend on Kubernetes, if you use Docker, if you use API testing tools, there is actually quite a lot of things. And for example, if you deploy to Amazon, there is the whole local stack available as a test container. So you can deploy these services and use the SDKs within your tests. Some implementations also provide additional logic, for example, asserts. So you have a database, you can run your application against this test database, and then you can use this framework to actually query database and ensure that actually you got the data you needed. So it's quite helpful when you use these services. And one thing that people all think about, that containers might be slow, but actually it's not exactly true. Because test containers uses a lot of features. For example, it can build images on demand. It can cache and suspend images. For example, if you have a database, you suspend it and then bring it up only for the tests and then suspend it again. You can also do graceful termination, so you do not have to care about resources. And actually, container reuse and tracking is what you can do. And if you use modern versions of Docker or Podman, it's another engine. You can actually also use checkpoints. So for example, you have a container. Let's consider it's a virtual machine snapshot. So you executed something, and then you can suspend. You can have basically a recovery point in this virtual machine or container, and then you can return to this breakpoint with all the state, with all the configuration, and with clean environment. Obviously, there are some potential issues there. For example, if you are testing time zones, etc., most likely this approach won't quite work. If you test a real-time operating system, most likely this approach won't work. But for many common services, it does quite well. So test containers has been available for many technology stacks. And for example, just to show you, this is an example in Rust. It's probably even more wordy than in C++, but there is Rust, there is Golang, and there are other languages which are actually close to C++. So I know that, is it allowed to pronounce Zik at this meetup? Okay, so there is no test containers implementation for Zik. Okay. So test containers for C++. For me, it was, to some extent, conference-driven project, but also customer-driven project, because we had a customer who was interested in this tech. And I started this project in September 2023, mostly targeting embedded on automotive. And actually, it's based on test containers for Go, not for Go. And there is a WireMock model, which I basically presented briefly already. So how it works under the hood. So this is an example, I believe, for something. Well, it's just a main class, so it's basically usage of shared library that is being produced. And it's basically the same as I presented, but it's written in C. So test containers for C, C++ at the moment is developed in C. And you can basically use low-level API to define what you want to provision. And then you can just use it and test the results. I don't recommend using test containers for building any production code, but for tests, it's actually doing quite well. So what we achieved by test containers, we extended support from this, except C and C++, again, there is a mistake, to actually this. So for example, I used test containers for C, C++ to run MATLAB with Simulink and actually verify against my test project and database to ensure that it works fine. And I also used Simulink to run open SCADA service. So open SCADA is one of Russian open source projects, open source SCADA system. I guess you might use other similar projects, but you can actually use test containers, use headers, etc., to connect with other tools. So it expands the support quite well, and this is actually added value. Is anyone familiar with Golang? Okay, so Golang is a language by Google that intends to be simple. So let's say it's more simple than C++. To some extent, it's more simple than C, but it has some additional features like garbage collectors, parallel processing, some asynchronous behavior support. So it's a low-level language. It's very wordy, but it has been quite popular in the cloud-native space. So there is one test containers for Go. It's an open source implementation. It's quite powerful. And when I was thinking how to implement test containers for C++, to be honest, I started from Rust. I wanted to use test containers for Rust for my implementation just by doing binding. It didn't work because test containers for Rust wasn't as stable enough, as well as developer tooling. So at some point, I resorted to Golang. And basically what I did, I took a C adapter. I implemented C adapter for Golang. There are projects for that. I also implemented some additional headers, add-ons. And then I used a project called CGO. CGO is basically a way to build C-compatible libraries or executables from the Go code. So in my case, it can produce either shared or static library and header files, which you can reuse in this project. And it runs with C quite well. So then what you can take your project, you can take your test code, and basically get a test executable that you would be able to run in C++. So this is how it works under the hood. So there is not so much C++ code in this implementation. There is mostly Golang, but it works for C++. And how it works? So the project itself is built with CMake. So any project that can use and any tool that can use CMake as a source. So for example, Conan or just fetch content in C++, I believe TP build and everything else, they can just use this project. And so this example for CPM make, does anyone use it? So it's my favorite package manager because it was created before VC package was a thing. And there in my CMake file, I just say that I want test containers for C, particular version from GitHub. I pass the options, and then magic happens, and this project can be built for me on demand. So basically, when I write my demo, I just include test containers for C, C++ right from GitHub. So I don't even build binary distributions at the moment. And well, I keep my fingers crossed that every built environment will have a proper Golang version, etc., to actually reproduce the build. So this is how it works. I still have quite. How are we doing with timing? Because I kind of I went completely off track, which is good, but at the same time, I have no idea where we are. Okay, so I guess this is time to actually show you how CMake file looks like. So basically, this is the same demo as I was presenting. So here I use CMake, I use WireMock Google test. Well, it's basically my project. I use C++ 14, and there I basically just include CMake. So CMake is included here as build files, but you can run CLI, etc. So it's basically a bunch of additional CMake code base. So in this project, I have 93% of CMake code and 7% of C++ code. Yeah. It's not how I would suppose this project to look like. But then I also use fetch content. I could also use CPM make for that, because CPM make also has a wrapper for Google test, but it's not really needed. So I use the most recent version. I just download from GitHub as a zip file, exposed to my environment. Again, it gets built. And then I say that actually I will be building a test library, which will take my test data files to proper directory for testing. I add executable, all the dependencies. You can see that I don't actually build it because it will be built automatically by CPM. So it basically adds a model to my CMake project, and it appendages on its own. It has cache. It can reproduce the build, so it's quite fast. And at the same time, then I just use Google test and I run the test. So this is the CMake example. Let's just clean everything. So just to show you how fast it builds in this configuration, because we actually rely on the build cache too. Well, it's supposed to run fast, but you never know. So I clean the dependencies. So it still rebuilds the code bits. Then I just built everything. And this is basically the last step we are going to test. So you can see that, well, it's fast because it uses local build cache. So even if you clean local environment, clean all CMake, etc., with CPM make, you can actually get items from cache. Well, again, there are many other implementations like that, but if you want, you can actually build the artifact from scratch. So this is how it looks like for C, C++. I can show you a few more examples while we are here. So I'm not going to build test containers for C itself. If you want, I can show how the internals look like. So probably you will never want to build Go to C bindings after that, but yeah, let's see. Yeah. Okay, so it's basically test containers for C project. It's an official project on the test containers repository, as well as other implementations. And here, so as I said, there is a lot of magic there. So all the magic is here. We can take a look later. But I wanted to show you a few demos you can find. So one, for example, is a generic container, which I believe just use ctest. Just a second. Yeah, it just uses ctest, I believe. CMake. Yeah, you can see I get quite a lot of different notifications, but yeah. You can see that there I just set up the requirements. I have this test binary, and this test binary is actually a bunch of code. So by this definition, I say that basically this main file will be started every time I execute tests. And tests are triggered on the build. So here, when I defined directories, so in my build, I say that I want test containers C, I want demo models, unless I skip demos. So why it's needed is because one, ECPM make, if I don't skip demos, it will be also trying to build demos, which takes quite a lot of time in downstream, and it's not something I want. So I basically have this flag here. And then, yeah, all the demos basically are implemented as a separate test, so they get launched and then get executed during the build. So the build for this project, yeah, it might look quite complicated. The whole complexity actually lies here. So this is actually a Golang code. So I will briefly show, well, this is how Golang package management looks like. So you can see that we basically download half of the world here too. Well, it's quite common. And we use Golang recent versions. We actually include Docker client. We include test containers client. So all of this code will go to a shared library. So all management connectivity will come from here. And yeah, there is quite a lot of stuff. And in our CMake file, so what we say that, yeah, we actually include things. So all our build happens here. So it's go build mode C shared. So it creates all the libraries, etc., for reuse. And then we basically just inject things. And the only file we have here is this test containers for Go. So you can see that there is a lot of Golang code. But actually what it does conversion from Golang library, which actually has structures, which has methods connected to the structures. It has custom data types. And not all of that is portable to C, C++ straightforwardly. So there is a conversion library. And here we just implement methods that will actually convert types. So for example, here we say that there will be test containers request, so what I was showing. It will be taken, well, it's basically a pointer to char, but it's a Golang type, and it instructs cgo that it needs to convert in generation to C type. So when we generate, it actually gets exposed. And here, so basically, we have some logic. And when we build this project, so basically, cgo takes this definition of the code base, and it takes all the libraries, etc., we include, and then it generates the header file and also the shared libraries, etc. You can see that it's so files because I built everything in VSL, even if while running on Windows, but you can get DLL with the same. And here you can see that there is quite a massive file being generated. It's being generated for C, it injects structures. Actually, this part is a bit annoying because it injects names like that. I'm about submitting a pull request that actually it introduces proper field names. And of course, for C++, it would be nice to have, again, classes and proper type binding. So it's something on my roadmap, but for now it generates like that. And then you consume it in your code. And moreover, you can actually create additional models. So for example, for WireMock, as you've seen, there is a model that uses WireMock. And this model actually extends the implementation by adding additional methods that are specific to WireMock itself. So we say that we want mapping, etc. And these methods use actually test containers H and dynamic library to build another, well, in this case, it's actually static library. Dynamic library, sorry, which actually adds additional methods that I reuse, and also it's a model that I produce in distribution. So it works. It's a little bit complicated, but once it's distributed to your machine, you can just use it and get all the results, and it actually works quite handy. So I will skip quite a lot of slides. But yeah, regarding WireMock, we already talked what is it, what it does. So yes, there is an official model for 5 languages at the moment: Java, Go, Python, Node.js, and C++. So C++, test containers for C++ is experimental on its own. If you like Golang, it's available too, pretty much like that. And yeah, so this is basically the demo I was presenting to you today. So you can find more information how it looks like, how to use it on WireMock website. So there is a solution, there is documentation that we are reworking the documentation site at the moment, but here you can find a lot of technologies WireMock integrates with. And for example, if you go to test containers for C++, to C++, you get description of test containers for C++, then there will be slides, video recordings, a few examples. So there is information you can find here, and yeah, it's something that can get you started. So for test containers itself, there is a GitHub repository. Everything is open source. You can try it. Patches are welcome. It's an experimental project. So today I released version 0.02. So everything, everything is being developed, but you can try it there. And if you want to reproduce the build, you can just go to GitHub. So I use GitHub Actions to automate the builds. Again, I could use TP build. I guess it would be much faster. But even here, so you can see what actually I use. So I use CMake. I also install Golang. Well, I don't even install Golang in this particular example because, yeah, everything is bundled in CMake, so CMake can install Golang for me in this configuration, and I just run the build. So basically, this is all the configuration you need to mimic to build your project. So for the demo I presented today for GoTest, again, it's public. You can take it from here. So I shared the slides, so you can find all the links. And yeah, there are basically examples which I was already presenting. So what's next for me? So yeah, it has been quite a project, to be honest. WireMock itself has a massive public roadmap with different integrations. Like we have some binary protocols, asynchronous protocols, like for example, Kafka, to be integrated. And specifically for test containers for C++. So I want to integrate more features because test containers for C++ is a small shim of test containers for Go, and there is a lot of other things that could be added. I also want to have C++ adapter most likely as a header-only library. Of course, con, VC package, more documentation, and actually addressing feedback from users. So for me, the most important part is to get feedback. So this is why I came here, to show these tools, etc., and to understand whether it's even useful to the audience and see what you would like to see. So yeah, key takeaway, shift left your integration testing with test containers or WireMock, depending on users' cases. So test containers can be used for provisioning every service. You can package in Docker, which is pretty much every service these days. And WireMock can be used for mocking services that cannot be either packaged or do not exist yet. So when you have a concept, you can prototype that. And yeah, my recommendations that definitely you do integration testing, definitely do API mocking to improve performance. And if you use C++, actually, it's no exception. You can actually build the stuff, and you can use existing libraries and existing tools for achieve pretty much the same developer experience as for Java, Golang, .NET, and other high-level languages. But in C++ and even C, and well, in Lua too. This is what I try to do, and if you are interested to participate and contribute, this is something I would really appreciate. So there is public repository, GitHub issues are open, there is a Slack channel where we can discuss the stuff. And yeah, if you're interested, just start using WireMock and share your feedback, start using test containers, share your feedback, just try the demos and say whether it's completely nice, whether it works on your system or not, because there is a lot to be improved. And I hope to spend quite a lot of time in this ecosystem, so any feedback would be welcome. Okay, any questions? Does it even make sense for your projects, for your tool chains? Who does do networking in C++? Okay, so if so, most likely you would benefit from these tools, and yeah. Well, then anyway, thanks for your time, and any feedback is welcome. Okay.